Good morning. Welcome to Chemistry with Emma. Today I will be teaching you about two very important laws in chemistry, Boyle's law and Charles' law. We will start with Boyle's law, which is an ideal gas law. This is about the relationship between volume and pressure. Unfortunately, the relationship between volume and pressure is not that great, and as one goes up, the other goes down. They're inverse. This method that Ms. Nielsen taught us with the flashcard is a very helpful way to visualize how Boyle's law works. Here is an example of Boyle's law. This is supposed to be a bicycle. It's not drawn very well. But this bicycle got a flat tire, so obviously you have to pump the tire back up. When you go to pump a bike, you use the bike pump and you pull up the handlebars, which decreases the pressure within where the gas is, so there's more space for the molecules to move around in there. When you push the handlebar back down, the pressure of the molecules increases because of the decrease in volume, and the molecules are now more tightly packed within that area. Now we will be moving on to talking about Charles' law. Charles' law covers the relationship between temperature and volume, and unlike Boyle's law, they have a far healthier relationship and are directly proportional. As one increases, the other increases. To use this example again, we can see how temperature and volume always move together as one. Imagine you had two balloons that were equal to one another. Now, one of the balloons was left out in the regular day temperature, maybe 70 degrees or something, and the other balloon was taken and put into a freezer, where it is significantly colder than the outdoors. What we'd find is that the balloon that was in the cold would actually decrease in size, while the other balloon would remain the exact same. These balloons are made up of gas particles, and we know that if the temperature is higher, there will be more kinetic energy, which means more space will be taken up. So in the cold balloon, there is far less kinetic energy, and the molecules would take up far less space, so the balloon ended up shrinking. Whereas the big balloon stayed the same because the gas particles needed that space. Thank you for listening. I hope this was helpful, and have a great summer.